Hello, my name is Jay Carpenter of PHONEWORD Workshops, and today is Wednesday, January 21st, 2015. It is 11 a.m. Eastern Time, and we are having part two of our January workshops. We're going to be talking about ENUM Registry Federation, WebRTC, and blockchain technology. And we're going to uh, primarily focus on blockchain technology today. Last week, the session on the 14th of January, we focused on WebRTC primarily, and in particular, AT&T's new offering on WebRTC and their platform that was rolled out at the Consumer Electronics Show. So far, I am delighted to have a special guest with us today. We have Nam Nguyen of A True Network with us, who coincidentally happens to be here in Arizona, Phoenix, Arizona, and is also a graduate of Arizona State University, where I'm an undergraduate from. And Nam is an expert in blockchain technology and marketing services and strategy surrounding blockchain technology. So, Nam, is there something you'd like to say about A True Network and what you do, and a little bit more of an introduction about your interest in blockchain technology?
Sure. Again, like what Jay said, my name is Nam Nguyen, and so basically, I primarily am currently focusing on kind of consulting work for marketing and business development in the crypto space, such as blockchain technology and cryptocurrencies such as Bitcoin. So overall, I've been interested with Bitcoin for several years now, and as the technology develops and the interest and the venture capital is being injected into the space, we're building infrastructure that's going to be very interesting and disruptive to what our current idea of what how technology should operate as a centralized service, and how can it operate as a decentralized service.
Awesome. So, thank you for that introduction. I agree, this is, in my view, the potential for disruption is huge. I've been holding up WebRTC as a disruptive innovation, and I'm new to blockchain technology in terms of its applications outside of the cryptocurrency space, but from what I know at this point, I am amazed at the breadth of applications that are being talked about for blockchain technology. So again, I am just getting introduced to the notion of blockchain technology outside of cryptocurrency, and I think most people have heard of Bitcoin as a cryptocurrency, and they have some sort of idea about Bitcoin. They might have an inkling about the blockchain technology that's associated with Bitcoin, but at least in my world, it's a very new conversation about applying blockchain technology to things like registries, internet domain registries, uh, insurance contracts, uh, governance. That's huge. So we're going to explore that a little bit. I'm going to start off by just quickly reviewing the presentation for January. We're not going to spend a lot of time on it because we went through it in detail last week, but I will kind of go through it just to sort of set the stage for the balance of the session today. So bear with me a moment while I start the screen share. Okay. Okay. So, can you see that okay, Nam?
Yes, I do.
Okay, great. So, the question is there room for innovation in and collaboration and exploration and experimentation in the areas of combining federated registry architecture, WebRTC, and blockchain technologies, or blockchain technology? So, looking at slide number 4, one of the problems that's being addressed here is the idea of address chaos. So we all face this issue of having all these disparate addresses, disparate elements that we deal with day in, day out, email addresses, telephone numbers, websites, social media addresses, all this stuff. And part of the first use case and problem solving is, can we, on slide 5, create some sort of address harmony possibility where all these disparate addresses start to work together? And frankly, just setting up these Google Hangouts, I think, kind of highlights the naming, numbering, and addressing space issue, because the invitations, the links, all that stuff could definitely be improved. And one of the things that we're looking at doing is making the setup of a video conference session as simple as dialing a traditional phone number. Even though you won't be dialing a phone number, you'll be dialing something that looks like a phone number, but it's not a phone number. And that's one of the key areas that's of interest to some of the other folks that were participating last week from the enrenum.net community, is applying something that's a simple way to connect in the realm of the academic and research arenas. So going on to slide 6, just kind of a highlight that we are in an exploration and innovation phase. Slide 7 just marks the 3 areas that we're discussing, experimenting with, which is a federated set of registries, WebRTC, but also in addition to WebRTC, also having some sort of compatibility with the legacy telephone network. And then the most recent item is, okay, what might blockchain technology offer in this mix? So going on to slide 8, just simply puts a question mark there. Slide 9 is an indication that, okay, is there a realm where these 3 things could start to complement one another? And the end goal is to see if either we've got a check mark there or no check mark. So slide 11, why federated registries? Well, federated registries offer a new realm of choice, redundancy, experimentation, government, and experimentation in the realm of governance and policy. So I've been involved with the ENUM initiative for over a decade now, and one of the big hurdles has been the notion of a golden tree, one registry basically to sort of rule them all. And the approach that's we're interested in investigating here is a federation of registries that's offers some experimentation and doesn't put so much reliance upon one golden tree. So we're interested in experimenting with that no matter what. Then WebRTC, what's the interest there? Well, the interest is that it's elegant, powerful, ubiquitous, versatile, and open. And browser-centric, rich media, I think, is very, very compelling, and we're starting to see some movement in that area. A couple weeks ago, AT&T launched a WebRTC platform at the Consumer Electronics Show. We talked about that a lot last week, and hopefully we will have some additional conversation about that and some experimentation using the AT&T WebRTC platform. We had Penn Faust from AT&T with us last week, and Penn is a person that I consider to be one of the top experts in the realm of public switch telephone networking, and as well as internet and possibilities in the realm of the regulatory issues that will surely arise here. So that's another area we're interested in investigating and hopefully having some successful experimentation around. Now we introduce blockchain, and this is slide 17. What is this? Well, blockchain, in my view, is kind of like a contemporary chain of title. Something like if you've ever bought a piece of real estate, you'll know that there's a title history associated with real estate. Well, blockchain technology, as best I can determine at this point, is sort of bringing that whole thing into the contemporary and applying this title history, if you will, or public ledger to a whole new realm of applications. And what's the advantage? Well, it's Swiss neutral, it empowers choice, it's dynamic, authority is rapid, consensus can be rapid, it's market driven, it's open, and it's end user centric, and it's decentralized. And I'm sure, as Nam will point out, you know, there's pros and cons to all of that, but the potential here is huge. I'm going to switch over to a video, and you can pick up the URL for this in the upper left-hand corner here, but it's www.theprotocol.tv and adept-demo-IBM-Samsung. I highly recommend, if you're new to blockchain technology, or even if you're, you know, very familiar with it, I highly recommend you watch this demo. We're not going to watch it right now, but it's quite exciting, and it's quite interesting to see companies like IBM and Samsung experimenting with blockchain technology, and they're experimenting with it in the realm of the Internet of Things and weaving in some very, very interesting applications. As I was setting up the Google Hangout today, I noticed that this article just appeared in ZDNet. Is blockchain the key to the Internet of Things? IBM and Samsung think it might just be. I haven't read this, but it's another indication. This was January 21st today at 11:55 GMT, and I think there's a lot of interest that's starting to emerge around this blockchain technology. While I'm on the subject, or actually to revert back to the WebRTC, I'm going to switch over to this site. This is the AT&T WebRTC platform. You can see that you can download their SDK and the documentation and start to experiment. So this is where you can get information about the AT&T's recent platform that they're testing and developing for WebRTC. Going back to the presentation, so why blockchain technology? Well, I think it offers some really, really interesting applications in the realm of naming, numbering, and addressing. and beyond. So this is a global opportunity, and this particular image highlights that there's basically no boundaries on the map. The Earth is truly flat in this space, in my view. And again, this is I think it's a collaborative opportunity to start to experiment with what essentially is like multiple land registries in a collaborative fashion. I would like to point out that I think proprietary offerings in this space is going to be very, very difficult. So I'll just leave it at that for the moment, but everything that we're talking about is open source. And again, part of that open source foundation is to foster collaboration. And this opens up whole new business realms and whole new ways to innovate, monetize, and create not only the technology but also new business models, governance, and policy. So here's some resources to take a look at. There is a free registry for enum and domains. cz.nic has been operating since, I think, 2004 or 5, maybe 6. We had a session for the November PHONEWORD Forum where we had Jaromir Talir from cz.nic, the architect for Fred, along with Henning Schultzrenny, and we talked about the Fred registry and what it might offer in terms of a blueprint for moving forward with, let's say, registries and a registry framework that's developed from scratch today. The WebRTC, in your presentation, there's a link to the site that I just showed you. The blockchain technology and platforms, well, the one that's making the most or getting the most attention right now is something called Ethereum.org, and I recommend you take a look at that. That is taking the blockchain technology and starting to add some intelligence to it, and some a whole bunch of things. Ethereum's about a year old. Last year they raised $18.4 million in a crowd sale, and there's been some articles that have been written about Ethereum, and I think it's well worth your time to take a look at what they're creating and the direction they're going in. So, summary and next steps, and we're not ending by any means, I'm just scrolling through the presentation. But the idea is to foster collaboration and create open source software, which I talked about, experiment with federating enum registries, experiment with dispute resolution, and that's easier to do with a market mechanism, experiment with governance, build experimental platforms, have guest presenters, and coding sessions. So part of the goal out of today's Workshops event is to invite at least 2 developers to step forward that are interested in working with me to write code. I am learning, well, I'm beyond learning JavaScript, but I'm not an expert in JavaScript by any means, but I am spending quite a bit of time learning JavaScript in depth, as well as MongoDB and Node.js. So part of the intention here is to build something. I'm leaning towards mean stack, which is MongoDB, Express, Angular, and Node.js. But we're open to conversations there. The other part of this is experimenting with ways to fund an initiative that is created in a Swiss neutral fashion. So one of the things that I like about Ethereum is they've raised their funding, $18.4 million, in a very Swiss neutral fashion. They're not, you know, they're not controlled by a particular venture capital group or any particular entity, as best as I can tell. And I think there's some in this particular application, this particular space, there's a lot of appeal to that. So that's about it for the PhoneWord Workshops presentation. Before we go back to the Hangout, I'm going to show Nam's site, A True Network, and he deals in strategy, implementation, execution, and in cryptocurrency. So you can see some of his areas of expertise, but in particular, expertise on emerging Bitcoin, blockchain, and crypto 2.0 industry. So with that introduction, I'm going to go back to our Hangout, and I'm going to stop the screen sharing. Let's see. Okay, so Nam, thank you again for joining the PhoneWord Workshops event today, and I'll just kind of turn it over to you. What would you like to say in addition to what I just articulated about blockchain, particularly in the realm of registries, internet domains, and that arena? And if you could tell us what got you interested in blockchain?
Right. So, what got me interested into the blockchain was actually what some would consider the blockchain's first true application, which was Bitcoin. So, Bitcoin as a cryptocurrency, some view it as the first application for blockchain technology. And so, Bitcoin, it was kind of my entry into understanding what blockchain was actually capable of. And as I dug a little bit deeper, not just from holding a alternate crypto digital currency or the internet currency that was being developed that was exciting, it was seeing what else that this blockchain mechanism was capable of doing. And so one of the core things about blockchain technology is really about a couple key things that is important that can be applied to cryptocurrency or things such as smart contracts and registries is the concept of the consensus mechanism. And so the consensus mechanism allows the system to secure itself to prevent any single one entity to actually forge transactions, for example. And that's really important that I think applies to the current discussion here about registries and domains, is because the blockchain at the end of the day is a distributed ledger that every system that is running this client has a complete copy of the full blockchain that they all compare with each other and agree that they have the exact identical transactions logged into their ledger. And so that's very key. So when it comes to domain for registries and domains, the blockchain is actually a very natural thing for that, because our current system, for example, either domain registry or even federated registries, there's still a form of centralization. That if there's regulatory type of issues, they can be shut down. While with blockchain technology, any single individual with enough processing power or with enough kind of like what they call stake can actually contribute to securing the network. And I think that's one of the most exciting thing about it, is because with the blockchain, not only is all of your registries and domains distributed, but also the key thing is that the blockchain will allow ownership to be associated with each of the domain, and that's secured through something that's very unique with the blockchain is having your domain address or your public address that's associated with your private keys that only you have access to. So the moment that you or the system, the blockchain, issues you the ownership of a domain address, you own it and you have access to change it because only you have access to the private keys. If you lose those private keys, then the system itself cannot recover your lost domain. And so at the same time, as much as it provides its security, it puts it puts responsibility onto ourselves rather than a centralized system, if you will.
Great. Will you talk a little bit about proof of work versus proof of stake? That's something that I'm interested in. However, I'm not quite clear how that is defined within this realm.
Sure. So proof of work, which is what Bitcoin was originally developed under, it's basically associated with the consensus method. So proof of work actually uses CPU power to do these complicated hash functions, which are kind of like mathematical puzzles. So when these mathematical puzzles have to be solved to actually secure the network. And so every system that runs the client will have to run these hashes to actually find a block. But the interesting thing is there's a race to get to where someone finds a block where they actually issue out new coins or new Bitcoin. But hashing, proof of work itself, is a system that actually use heavy CPU computational power to solve these complicated puzzles, mathematical puzzles. So that's one way of securing the network. So everyone that's running the system are solving puzzles and processing transactions while they're solving these puzzles to secure the network. So that becomes an issue of who has the most hashing power, who has the most CPU power, and these types of power have actually evolved from just using your CPU to using specific your graphics card to solve these mathematical hashing problems, and then also to FPGAs, which are very custom field programmable application devices that allow you to have a quicker way to solve the problem, and then finally eventually evolving to actually specific ASIC chips that are custom designed to secure the network and solve these mathematical puzzles. That's all they do. They don't. These chips don't do any calculation for your Excel spreadsheet or word processor or what YouTube videos. These chips are specifically designed to solve this proof of work mathematical puzzle, and that's exactly all it does. And it's designed really to actually lower the energy cost to do these calculations. And that's why Bitcoin itself that uses proof of work becomes a very expensive to the network. Millions of dollars a day is spent on energy to secure the Bitcoin network and all the transaction that occurs within it. Now, proof of stake.
Before we go on, I'd like to make a couple comments, and I think that's a great explanation of proof of work. But what comes up for me out of that description and what I've heard about proof of work and some of the problems with this intensive computing power that's associated with Bitcoin is that because there's this strong monetary component to this whole ecosystem, it seems to have pushed a lot of resources to really develop and focus on this intense computing power, and it looks like that's happened in a rather rapid fashion. and you're kind of echoing what I've heard in other places, that it seems to be rather wasteful to have this ecosystem that's set up for this intense computing power, where there's just this huge race to see, okay, who can have the fastest processors, who can hammer the system the most with this intense computing and problem-solving power. Would you say that's the case?
Yes, I definitely agree with that. Yes, most definitely. It's reached to the point where the community itself is questioning if this is sustainable from a financial aspect compared to the price of what Bitcoin costs. So the community and the Bitcoin community has to pay these miners that are running these miners are basically these computers or the people that run these systems. They call them miners because they mine these coins that every 10 minutes, is the fact that you have to pay them if there's a payout, because every time they generate coins they have to sell it for a certain amount. And so we're actually paying a very, very expensive amount to secure the network. Now, eventually, the question comes in is there's a balance between how much are we willing to pay for a decentralized solution versus what can we get away with a centralized solution. And that's where the evolution of the technology is really going to be headed. And that's why, where we're kind of alluded to was others have seen that that's not sustainable and have come up with something like proof of stake, which doesn't require heavy computational power.
And will you elaborate on what proof of stake is, how it works, and the overall concept behind it?
So proof of stake, on the other hand, instead of having everyone running, for example, the client or the wallet on their system, doing these computational processes, heavy puzzles that really it was specifically designed to be difficult and harder the more people join the network. Proof of stake was specifically designed, rather than Bitcoin and proof of work originally was designed at, it started at 0 Bitcoin, and every 10 minutes, starting from its genesis block, would produce, it was originally 25 Bitcoin every 10 minutes. So it started from 0, and it's going to grow to 21 million Bitcoins, and it'll stop there as a hard stop. But proof of stake took a different approach, and they actually had a pre-issue, for example, of just a predefined amount of, for example, a million, for example, like peer shares is an example that use proof of stake. So they issue out 1,000 of these so-called coins. A million coins, and then they start slowly distributing these million coins that already exist to other people, or they have to buy them, or they get granted to them. And so the network is now, rather than looking at who has the most computational power, looks at who has the actual certain amount of stake. For example, what's your current coin holding? So your coin holding becomes a percentage of your chance of winning this kind of random lottery of you processing the transaction. And when you process the transaction, you help secure the network and all of the processing. So it becomes, proof of stake is more of a lottery system in the sense of how much coins do you own compared to the total supply. But it doesn't use computational power to do these transactions, and never really did require that much power to do these calculations. For example, proof of work takes about 10 minutes to process a transaction versus proof of stake, which is more energy efficient, and that takes about 1 minute to, for example, 10 seconds to process a transaction.
Okay, great. And would proof of stake be somewhat analogous to, let's say, in the homesteading arena where, I think it was 1862, the federal government opened up the land um, west of the Mississippi, and basically you could go out and make a claim, and then if your claim was not challenged after a certain period of time, you basically that you perfected the title in your particular stake and claim to land. I know it's a little bit different mechanism, you know, at the outset, but I'm just
Yeah, I wouldn't say that's a direct correlation because your example is more of here are these available land or assets, and people can just go claim them. That's proof of stake doesn't do that. Proof of stake basically usually has a distribution model, whether they distribute all to the original creators and founders, and then they give it away, or they do snapshots of something else and they give it away that way. But it's usually or they release it into the market and let people buy and sell it in the market on exchanges and let it discover its original own price, if you will. But other than that, that's one of the downside of proof of stake that people are concerned about is the distribution of it because it already exists. The original founders have access to it. They decide how they want to distribute those coins. But from a proof of work, you have to work for it. You have to earn it. They don't exist unless you actually put in the time, energy, and power and money to actually go physically mine. Like you would have to go mine gold and gold out in a mine. So that's why they say the original thought of proof of work was more like actual mining gold. You have to actually put physical labor in and energy to actually get something out of it. Proof of stake is just basically I generate 1,000,000 of these and I'm going to decide how I distribute it. And the market will, through the market making and exchanges, will determine its value.
now, is anybody experimenting with sort of a hybrid approach to that combine?
Yes.
Okay, go
So,
ahead.
so in the crypto world, there's Bitcoin, which is the most exciting, the most interesting that everyone's talking about. But then with the ability of it being open source, people have forked it and have done different things with it. So it's become these altcoins have become a massive experiment, if you will, of people trying different things, of adding features that Bitcoin doesn't have. And so I think proof of stake is an example of, oh, I'm going to do a different consensus model that's more energy efficient. So there's other coins such as a blue coin, for example, does a hybrid of a proof of stake and a proof of work. So the theory behind that is by providing two types of consensus method, it's harder to attack the network because not only do you need to have more processing power than everyone, such as more than 51% of the processing power for everyone, which is what is required to compromise the system, you also now need to own more than 51% of the total issuance of the stake that was originally distributed. So you need to attack two vectors, and they're two different vectors.
And is that BLUE coin?
Yes, BLUE coin.
Okay, great. Take a look at that. Well, that's interesting and I would say encouraging. Any other innovations that you've seen out in the space that you think would be of interest to this community?
Yeah, most definitely. So there's the best way to break up what's currently happening in the space for the blockchain is number one is, for example, like what we discussed before, a registry or a domain type of solution, a domain registry type of solution that can be distributed, right? So that's one. And BitShares is actually working on releasing one for for a more decentralized DNS system. And then the other thing that's also interesting is a voting mechanism, right? So Ethereum is an example because they're building a programming language on top of the blockchain, integrated with the blockchain, to allow voting on the blockchain. and BitShares is also doing a voting type of blockchain. So basically, voting is very interesting because it's anonymous voting, but it's verifiable. Verifiable that this certain public address voted for this specific person, but at the same time, we don't know who that address belongs to, and so that creates what we call it's anonymous, but it's verifiable. So meaning that President A had so many votes versus President B, but you don't know who actually was voting, which is what we need in our society. Is that what we need? Is the anonymity of it, right?
Mm-hmm.
So voting is interesting. Another interesting coming up in the place in the technology space is, for example, tokens or user issue assets. So, for example, or some call it crypto equity, if you will. So, if you are a company, let's say you're a small business, and you want to raise funds to expand your business, well, without any complications, you can do an initial crowd offering and issue out, let's say, 1,000 coins, and release it to the market, and people can buy those coins at $100 a coin. So that way, you now own a part of that company, but because they've issued those coins, and they can issue you dividends and such like that. So technologies such as that come from companies like Mastercoin and Counterparty that will actually allow you to do these user issue assets or even tokens that the general, for example, school can issue out tokens for the kids to use, or nonprofit organization can issue out tokens. So these tokens are very interesting because now you have primary, like Bitcoin, for example, as a more of a you know currency that people use worldwide, versus a community token that people can use within the community itself or small groups.
Cool.
And then the other interesting thing is probably, I would just say, smart contracts. And so smart contracts is kind of what you alluded to with Ethereum and all of these other people building technologies such as sidechains on top of Bitcoin, is the fact that it allows you to make programmable logic and contracts onto the blockchain. So, for example, we can write a smart contract that says that you want to borrow $100 from me today, and then tomorrow, let's say a week from now, you have to pay me back, and you have to put some collateral, and that collateral is held on the blockchain. And so, eventually, in a week, the blockchain will actually automatically release it to me. So that's kind of how smart contracts can work, either from a monetary aspect, financial aspect, or it could, like you said, hold titles to your house, titles to your car. So the power of blockchain is really about removing counterparty risk, and so we don't need people to mitigate who has ownership of, for example, your property. The blockchain is written into the blockchain of who has that ownership.
Awesome. And how much activity are you seeing in the space of, let's say, organizations or entities like nonprofits or schools or whatever, issuing these cryptocurrencies that, in many respects, operate like shares in an organization?
Very low right now. So it's not publicly adopted, but it is the future. So it's something to keep in mind that it's going to be. But right now, it's currently in an experimental phase where, for example, um, crypto companies that are trying to do a startup are using it as a mechanism to raise funds for their business.
Mm-hmm.
And so right now it's at a level where it's too technical that a mom and pop donut shop can't issue out assets there. But in the future, as the technology evolves and becomes easier, the same way as how complicated the internet evolved for us to be able just to do one-click pay, you'll be able to log into an account, generate some tokens, and then broadcast it, and people will just buy your coins and invest in your company. So right now, it's from a general community aspect, it's very low adoption, but the tech community is actually using it to fund themselves. Is the best way. They're building technology to fund their own business, which is pretty amazing.
Right. And has there been any action, let's say, by the Securities and Exchange Commission, the regulators? Because I'm not familiar with what, like, Ethereum did, but it looked to me like it was basically an initial public offering. So.
Correct. So that becomes something of a legal interpretation, right? And so it looks like an IPO, initial public offering, but they can go claim that's a initial crowd offering. But at the end of the day, if it smells like something, it is that, right? That's how the legal language works. And more importantly is how did they define what you were actually buying or investing in? So is the SEC looking at? Most definitely. And for the amount that they raised, that's a very big flag because now it's a large amount of money and that's a large amount of liability. So are they completely free from any regulatory or fines that they could potentially have? That's up to the SEC discretion. I am, from the chatter that we hear, there's a lot of Bitcoin companies and cryptocurrency companies are being observed and they're being monitored just to see what they're currently doing. So it's a new thing that's unregulated, but definitely the SEC is looking at it as a concern, as a kind of like a protection for the consumer when it comes to millions of dollars, rather than, oh, you raised $10,000 from a group of people. Now you are raising millions of dollars from a group of people.
And quickly, with it looks like a minimal amount of friction. So
exactly. So there's no friction, and there's actually no, there's just no friction. So basically, for example, to give the audience an example of how these funding works is basically they have an address, and this lengthy address, but just think of it like a mailing address, and people can just send money to it, and that's how it is. And it's very easy to basically just run away with the money if they were dishonest.
Yeah, and I think that's another part to this whole thing that is critical but subtle, is reputation plays a huge role in the whole ecosystem. And your currency in many respects is your reputation. And if very much like the sharing economy now with things like Uber and Airbnb, you are allowed to play by within the community, assuming that your reputation meets a certain standard. But if you breach your reputation, then it's game over. And I think that's another critical element to this, what's emerging here around the cryptocurrencies and using blockchain in realms outside of the cryptocurrencies. Is there's a big reputation element that's part of the checks and balances.
And that's one of the emerging technologies that's going to be built around the blockchain, is identity and reputation. So that means that you will have an idea based on their system as how credible and how trustworthy is this person. Kind of like a web of trust, if you will.
Right. It's really, the dynamics of this are so amazing to me, because it's this, all of a sudden, all these different elements, governance, policy, law, social networks, transactional networks, organizational networks, all this stuff is coming together under this emerging construct of blockchain technology. Would you agree with that?
Yes, most definitely. And I think at the end of the day, and I mentioned it before, the key aspect to take away from blockchain technology is the elimination or the minimization of counterparty risk.
Will you elaborate on that a little bit?
So counterparty risk, for example, let's say you put your money in a bank. So that bank now holds your money. Or they may lend it out, or they may do something with it, but the day that you come and cash out your money, it may or may not be there. So that becomes a counterparty risk. So with blockchain technology, it removes counterparty risk because your money that you hold in your address or your account is written to the blockchain. It says that you own that. As long as you have your private keys, which is the key to unlock your funds to send it to somewhere else, is written in the blockchain, and that's distributed to thousands of computers that have agreed that you own these funds and no one can touch them. So that's an example of counterparty risk.
So effectively, Nam, it's like once something is published, it looks like it's impossible to erase it because of this decentralized construct. So it's sort of like if I get on YouTube or something and I make some sort of disclosure of something that was secret in the past, as soon as I say it, there's no taking it back.
There's no taking it back. So that's a good example. So if it's, let's say that you make the comment similar to a Bitcoin, it's a transaction. If there's a system such as YouTube's commenting system, then your comment may be written into the blockchain or some type of storage system, and it will just remain there. That's an example of the permanence that it can have. So for example, there's proof of existence as a technology where let's say you have you created some type of great technology, wrote it on a piece of paper, and you want to identify that you were the first person that created this, or that this existed. You can actually submit it into the blockchain. They'll create a hash, which is the unique fingerprint of your document, and then they'll write it into the blockchain. So then you can always send it to anyone, and they can verify that that document existed before someone else tried to steal your idea.
Right. So, Henning, you just joined us. Thank you for joining us, Henning. This is
being late.
No problem. I'd like to introduce you to Nam Nguyen, I think we've been having a great conversation about blockchain, and I don't know if you've heard any of it, Henning, but what Nam is sharing, I think, is right on point with the work that we've been doing in terms of the experimentation in the numbering test bed. We've just been talking about identity management, reputation management, the nature of the blockchain, how there's a responsibility associated with blockchain, and there's just whole new realms that are I think ripe for exploration here. So do you have any questions, Henning, about blockchain? What do you know about it?
So actually do have, this is a great opportunity. I've looked at the paper a little bit, but I haven't dug into this in great detail. One of the, echo here. Is that me, or should
It's
I?
a little echo. Do you happen to have any a headset that you could use? You have like a iPhone headset?
Yeah, that's one. Let me see if I can find one quickly that actually works.
Because it was a little difficult to understand you as well. So, and I've got kind of a hack here to pull in the conference bridge.
Okay, let's see. I get. Okay, I have a headset at least for my listening. I'm not sure if that helps. So in terms of a blockchain, oops, now I'm hearing myself.
Let's see. I'll tell you what I'm going to do. I'm going to disconnect the. I'm going to turn off the conference, and let's see if that helps. Testing 1 2 3. Testing. Bear with me just a moment. Okay, so I'm going to put on my headset as well, and we should be able to eliminate this this echo. How's that sound?
You sound echo-free, and I don't hear myself anymore either. If you can hear me,
Okay, good.
Everyone sounds good.
Okay,
Good.
great.
So well, I have many questions, but one that I'm curious about is right now. If I looked at it maybe a week ago. There were about 6,000-ish nodes that are part of the kind of a blockchain network, I guess I don't know how you'd call it precisely. I'm still not up on the terminology. Is that about right?
I don't have the statistics on that. It's always changing and evolving based on who can afford to run the network.
Right. So, but I mean, if we take about 6,000 or so, because, and you correct me wrong because I'm likely going to get technical details wrong, is the idea is if I want to add something to the ledger, I would broadcast my transaction to all the other nodes that are maintaining the blockchain. Is that right?
That is correct.
So I would essentially have to do a broadcast, and I'll ask you in a minute as to how that works, but technically, because the paper doesn't talk about that in detail, and so my concern is longer term. My sense is that for a Bitcoin type thing, like you said, is since it requires significant computing resources to participate usefully, because you didn't have to do the mining and all of that. But if you were to use it for other purposes that are not where there is no monetary incentive, it's not obvious to me that you can scale a broadcast network to whatever 100,000 nodes or some other significantly larger number. Is there any discussion as to the scaling if you start using the blockchains for non-monetary purposes?
Yes, there's actually there's discussions about it. There's obviously concern about it. For example, Counterparty example is a technology that's built on top of Bitcoin, and with Counterparty you can issue out user-issued assets or create tokens out of them. But those unique tokens, for example, is secured by the Bitcoin network.
Mm-hmm.
So they're using the Bitcoin network to actually secure the network. So that's kind of considered the blockchain bloat, if you will, because it's not being used for specific value transfer from one coin to another coin, but now it's being used to actually write small bits of information for a top layer application on top of it.
Right.
So that is a potential concern.
Okay.
And it's being
because it seems to me, I don't know what, I don't know if you have any idea, I haven't looked at it. There's a scale problem, as in broadcasting to 100,000 people seems to require different technology. Not as impossible. Obviously, we broadcast internet content via YouTube and others to, or Netflix to millions of people, so it's not impossible, but that's a network that's designed in a more hierarchical way, and you have content that's largely constant, I mean movies and so on. So the other question, do you know I don't know how deeply you're involved in the implementation side, is today for the broadcast among those nodes, it can't be that I need to know 6,000, let's assume for a moment that's how many there are, counterparties. There needs to be some kind of a topology superimposed on that, like an overlay, like in the good old peer-to-peer days, or how do I reach how do I broadcast information to all the other nodes?
Yeah, so I don't not that deep technically into the actual process of how that's actually being distributed through the network, but it's still similar to a peer-to-peer technology where you download the blockchain, you find out other peers, and you do that. So it is peer-to-peer technology.
Okay.
And so that's what it is.
Okay, because it must be, and the reason to some extent, and Jay alluded to that, I have been, not deeply, but my reason for investigating that is overall technology is indeed, can we use that for assigning numbers, and my sense is yes, I don't think it would be terribly hard to do. It's not obvious to me, and the number of people that you would have to have in the network would be much, much smaller, given that the number of entities that care about telephone numbers is really much smaller than people who care about money, or other purposes. But I was just curious. The other piece is, I just haven't had, you can probably explain this better than I've been able to just figure out by quick reading. So the notion that I understand it correctly is that so everybody who submits a transaction or any other piece of information that signs it with their private key and appends it to their local block and sends it out to everybody else who also appends it to the block. I assume it's somewhat of an ordering issue, in the sense that obviously in a large network, lots of people are going to do things simultaneously or near simultaneously. Is there any mechanism, because once you do the hash, obviously the order matters. You can't just dump it all into one bit bucket and sign it. It matters which order the transactions appear. Is there some kind of, I got the sense there was some kind of a global clock, but I'm not sure if there is, and how you make sure that when two transactions are generated by two entities, A and B, and they show up at entity C, that the ordering in all parties, let's ignore misbehaving parties, but all compliant parties is exactly the same. Do you know how that's done?
I cannot answer. I can't answer that specific detail.
Okay. And so, but maybe level up a little bit is, so everybody gets the block. Let's assume they all get the consistent one, and every once in a while, the block gets the clock ticks, and after some amount of time, a block gets signed, right? Is that, closed essentially, so that it can't be altered anymore, and a new block is started.
Right, every 10 minutes.
Every 10 minutes, that's what it is. Okay. Can you describe, as far as you, kind of from whatever level you've dealt with it, So every 10 minutes, when kind of a giant bell rings across the internet, and everybody does something. So what happens at that point? I'm a little fuzzy as to what exactly occurs to close out, to essentially seal off a block, if you like.
I guess I don't know if I can answer this specifically to what you're asking, but just to give you an example. So basically, how Bitcoin works when you transfer one coin to another person and you broadcast that out to the network.
Right.
Within 10 minutes, you get one confirmation from one device. And so over time, you will get three confirmation, four confirmation, until you get thousands of confirmations. So it just slowly trickles down through the network that way.
Okay, so, but in some, that actually immediately raises, like every good answer raises at least one more question, is, let's say I get one answer and that's all I get. That would indicate to me that there might be trouble because I'm expecting 1,000 answers. Besides getting some large redundant number of answers that basically all tell me that lots of people process the block in some way, why do I care as to that I get 1,000 answers as opposed to one answer? Let's take the extremes.
Right. So the 1,000 answer versus one answer comes down to basically because the idea of having a distributed network is actually is the consensus model. So
right.
Rather than having one person as centralized service saying that this transaction occurred, you have thousands of people saying and agreeing that this transaction occurred. So everyone's on the same blockchain.
Right. I know there's this notion that an attacker, if they wanted to do something bad, they would essentially end up, so to say, forking it, and everybody ignores it because it's the shorter blockchain. And so I can see, what I'm curious about is, you get a confirmation, but in some sense, it's not like you can go to Visa or eBay and say, "Yep, I paid, and now I want to get delivery of whatever I had." There's really no, when you got a bunch of digital receipts, but they're not in any way. They give you kind of a level of comfort, but they don't really tell you anything that you can take to anybody.
Yeah, so what the way that the community and a lot of the experts feel is the fact that one confirmation at today, no one's not too worried about that confirmation not going through, if you will, if you want to look at it that way, just because there's just not enough, they don't feel that there's enough computational power to actually compromise that security.
Yeah.
So the general consensus can at most is 4 confirmations, where there's enough confidence that that transaction is pretty valid and secure. Down to like 3 is kind of the number that I'm seeing, and some places will take it down to all the way about 2 confirmations. But like you said, that's the limitation that others view Bitcoin has, is the application may not fit well in a real-time coffee shop buying experience, because it takes 10 minutes to get your confirmation.
Yeah, right. And then particularly if you have if you get disconnected, you have to worry about what happens. There must be a mechanism what happens when you get reconnected, that you catch up with confirmations and all of that. It seems like there's a fair amount of machinery that needs to happen so that when people are not permanently connected, that they can still get the confirmations and know that they paid or not. So
yeah, so there's other solutions that are solving it. One solution that I was telling Jay before was called what people are building their own blockchains and creating their own unique coins separate from Bitcoin with their own,
like Dogecoin and all that. So
yeah, Dogecoin. So each of these have their different parameters to allow quicker confirmations, if you will. So proof of stake, for example, can do confirmations from 1 minute to 10 seconds. So BitShares, for example, can do is described to have Visa quality transaction speeds of 10 seconds per transaction. But if you look at Bitcoin, they are now doing, they have methods where these other companies are doing kind of analytics, statistics on the network, and can give you, you know, a 10-second confirmation before the actual one true computer confirmation actually comes in, based on statistics of the network.
So because the limit under 10 minutes seems to be because each block essentially encompasses 10 minutes worth of transactions. And
that's what's written into the framework of Bitcoin. That's like ingrained into the DNA, if you will. They just decided.
But like you said, others that use similar technology seem to be able to, and as the number of transactions gets larger per time unit, you might want to you might want to have block sizes that are not as huge for a variety of technical or just convenience reasons. So
right. So the so there's ways to improve. You know that. So the interesting thing is the Bitcoin blockchain is now a very big and yet very slow evolving blockchain now, right? Because it's high risk. It's billions of dollars in its market cap. So what's happening is they're building additional technologies rather than just having unique altcoins with their own unique blockchain. They're coming up with systems such as what is new, and it's called sidechains. So sidechains runs on top of the Bitcoin network, but they kind of operate on their own, and they can do different things also.
So, Nam, I have a question for you. It's kind of a little bit more general to Henning's questions. What are your concerns, or do you have concerns about the scalability of blockchain technology?
Blockchain technology as a whole, in a way, has no limitations. It's the limitation and the concern comes down to the consensus model. So the consensus model is either going to be proof of work or proof of stake. There's other consensus models happening right now, but those are kind of like so far proven and they're working in a sense. So they're trusted. So that's where it kind of comes down to. You know, proof of work everyone has the concern. Is this sustainable from a power consumption aspect to secure the network, and the cost of it affecting the actual Bitcoin economy? So blockchain, it's the proof of work is, depending on how it goes, can or cannot be sustainable, and that's a very interesting aspect. And proof of stake, you know, the concern is, was the distribution of those initial those coins fair?
Yeah, and as Henning, as Nam and I discussed before you got on, there are some hybrid models out there as well that are a combination of proof of work and proof of stake that are being introduced and to some degree experimented with. So,
okay.
What other questions do you have, Henning?
Yeah, I think that's already been quite enlightening. So I actually have to run pretty quickly. So I think for today, that's already been quite helpful, and I certainly appreciate the introduction. It's nice to get to know somebody, if virtually, who's more closely tied to that, because for a variety of reasons, I want to know a little bit more about it, because it does seem, and it strikes me, having been around long enough when the peer-to-peer networks first came about, is that it's in some sense a second-generation version of that, where it initially was meant for a fairly narrow purpose, kind of content distribution essentially, and then people discovered, hey, what we're really talking about is a distributed storage mechanism, and the difference here is that it has trust properties that the original kind of core Kadim layer type of mechanisms didn't have, or maybe on just signing content. But so in that sense, it's interesting as how general a tool is it, and some of the mechanisms, like consensus mechanisms, is scalable at reasonable effort, because that's, in some sense, if you look at the earlier peer-to-peer networks, you had in a different version the same problems, like misbehaving users, and people talked about proof of work there as well, and more in theoretical literature and in practice. So, we're in some sense it's a more sophisticated revisiting of the same old distributed computing and storage problem that we've had. So from that perspective, it's already been quite enlightening.
Yeah, awesome. All right, any other questions you might have, Henning?
Nope, I think I'm
okay.
Good for today.
Okay, Nam, anything you would like to say before we wrap it up?
I think, yeah, just to kind of wrap it up with the conversation that you have with federated registries and WebRTC, I think how does the big picture of how does blockchain technology come into play with that? I think it comes down to there's an opportunity for your community to take a look at blockchain technology to actually do some, for example, some registry on the blockchain and actual payment for those domain names or those phone numbers through the system and paying with those tokens. Those are potential solutions that you can have, and it's, aside from a federated system, a blockchain solution, whether it's proof of stake or proof of work, can be maintained by the network and the people, so that way that no central government can actually shut down the system that you're building. So that's one aspect. And then from a WebRTC, blockchain technology is moving towards allowing resources that can be purchased and used, such as distributed storage. That's what Henny was saying. Distributed storage, you can rent out CPU power. You'll be able to rent out virtual machines to actually run instances that the blockchain is negotiating with all these resources on the blockchain with these smart contracts.
Well, that's that's another whole dimension to this that's I think quite interesting to explore. Is I believe there's a conversation going on about tying broadband capacity and capabilities to the blockchain as well. So that's a whole area of discussion that I think is quite interesting. So let's go ahead and wrap it up. The next week we will have a PHONEWORD forum, which is designed to be more of an open, high level, even higher level than this conversation. I think and I don't have anybody scheduled for that, so I think I'm going to focus on continuing the conversation around the blockchain and maybe get a few other folks, invite them that are, I mean, you've done a great job, Nam, but I think the next step might be getting into some real technical details like Henning was talking about for the scalability and some of the mechanics. I'm not sure we'll do that on the PHONEWORD forum, but there's a strong possibility. And then we've got on February 11th, I believe, the second Wednesday, we'll have another PHONEWORD Workshops event, and I'm sure we'll be talking about blockchain at that point. The intention at this point, I'm really inviting the community to join me to write some open source code for this, and we've written a dialer, a browser-based dialer through the Bounty program, but I think we're really at a point where it's time to write some code, publish some code, put it out on GitHub, and really start to experiment with this. So my goal for this session is to have at least 2 people that come forward and say, hey Jay, I'm interested in tinkering with the code on this. Like I said in the beginning, I'm learning JavaScript in some depth, Node.js, MongoDB. I'd like to keep this full stack just so that there's as many people as possible that understand the language, full stack JavaScript. Also experimenting with ways to fund this. Again, I think it's important to keep the funding that's associated with this Swiss neutral as much as possible. And I think there's some awesome areas to explore with this blockchain tied to WebRTC and a federated registry architecture. So I appreciate both of you for participating in this. I know there'll be people watching this, and this is building a foundation to have hopefully a conversation that leads to some significant innovation in some key areas of security, networking, naming, addressing, and numbering, and so forth. So unless you two have any other questions or comments, we'll wrap it up for today, and I invite folks to stay tuned and follow the conversation.
Thank you, Jay, for setting it up, and we'll be in touch, I'm sure.
Okay, great.
Thank you for having me, Jay.
Thanks, Tom.
Thank you.
All right. Goodbye.